All right. So I'm Kyle Houchens. I'm a tech and a trainer for McNeil. Have been very, very fortunate to work with the folks at McNeil and Bob and all his crew, who are some of the coolest people I've ever had a chance to work with. So I'm a very stoked McNeil employee and have been for the 5 or 6 years that I've been working with these guys. I also run a design consultancy called the Outside Digital Art and Design, and so not only do I do tech support and training and stuff like that for McNeil, but I also run. I kind of have two full-time jobs. I run a design consultancy as well, and I make half my living at least doing design every day and modeling every day and stuff like that. Just finished up a big project. I do most of my work in the toy industry. Have worked in the toy industry for years for companies like Fisher Price and Mattel and Hasbro and Radio Flyer and Leapfrog and Spin Masters and MGA and you name it. I've kind of worked for them for a long time. So I've been doing that for a long time. I have built thousands and thousands and thousands of models, ranging in complexity from simple things like we're going to cover today, all the way up to models that have 10 and 15,000 surfaces and all sorts of stuff like that. So what I like to do with these sessions is a little different than probably most webinars that you see. And if you've if you've been to one of these before, you have probably seen the entire range from spectacular success to unbelievable failure and everything in between. We do these. I like to do these. I say we, but it's me. I share the blame if it goes terrible, and I share the success and I own the success if it goes well. What I try to do with these things is I try to do them live. I usually the night before, or in some cases the morning of, do a quick sketch or a series of sketches or something that we can build for these things, and then without practicing it beforehand. There's no Julia Child's, the raw ingredients go in one oven and the finished ingredients come out of another oven. Without practicing these at all, I like to just build them from scratch. And the reason that I like to do that is I want to put myself in the same situation that you are in if somebody were to walk into your office and hand you a drawing and say, build this, right? I don't want to practice this before. I don't want to give myself that luxury. I want to find my own limitations as a modeler. I want to find my own any limitations in the software. And in my mind, the value of these sessions are not only if things go well, we can all talk about how that happened and hopefully have a guide as to how to repeat that type of success. But more importantly, if something goes scattering into the fan, and makes an absolute disaster of something, I like to stop and talk about what happened and try and figure out how to fix it. Because if you've spent any time sitting in a terminal trying to model anything, you know that it doesn't always go to plan. And a lot of software companies don't like to admit that because they want you to think that their software is the greatest thing in the world and it never crashes and it never fails and the tools always work perfectly and every fillet is, curvature continuous and all. And anybody who's done this for a living for more than 10 minutes knows that that's not true, right? We all know that stuff doesn't work and tools fail and workflows fall apart and the best of intentions can go off the rails. And so I try to put myself intentionally in a position where something might go wrong that we can stop and talk about. And that's a little bit of a head scratcher of coming from a software demo point of view because people say, oh, it makes the software look bad. I honestly don't think that's true. I think what the actual truth of the matter and the reason that I try to do these the way that I do them and the response that I keep getting is that, man, I wish everybody would do software like, demos like this is we show you where things go wrong. We show you what happens if something goes wrong and how to fix it. So for today, I've decided to do a bunch of little, I'm calling this you know, knobs and buttons or whatever we want to call this demo. And I've just kind of built up a little portfolio of things here that we can take a peek at and try to go through a little bit. And each one of these things shouldn't take a terrible amount of time. Maybe we'll get through all of them. Maybe we won't. Maybe we'll just pick a few and go. I'd like to try and get this done by about 10:30 or 11 at the very latest. And so, you know, we'll start on a few of these, see how the time goes. Maybe we'll vote on which one to do next or whatever. But the one I'm going to start on is this guy. And the reason I like this one is because the intention is for each one of these grip faces to be very, very soft. And sometimes modeling soft things is a difficult task, because modeling sharp things is easy because you don't have to worry about any transitions and all that kind of stuff. And just trimming two surfaces together, you get nice sharp corners. Doing soft things can be a little different. And so I'd like to start with this one and then and focus on that. And then maybe we'll go over to this one, which would be, which seems like it would be very difficult, but there's actually a very easy way to do this one. So I want to show that. And then we'll pick a couple more, depending on how time goes. Maybe we'll get through all, maybe we won't. But I'm going to stick this over here because, and just to start this correctly, the way I start every project is with the picture command. I always start from a sketch, whether it's my own sketch or whether it's a sketch that's been given to me. This is just the conversation I have with myself, so I can sit down and start figuring out how I'm going to do this. And if we look at this thing, we know we have a nice rounded soft top. We have a little undulation and a little bulge in the center. There's a sharp edge here. There's a sharp edge here. This is soft. Maybe this edge breaks and this one doesn't. But these, if I'm looking at the section lines, I'm not seeing any sharpness in this whatsoever. The other thing is, it's kind of hard to tell how many grips there are in here. I'm assuming there's like 6, because if I you know, bisect this thing over here and I say, okay, there's 1, 2, 3 there, and I'm following around the back, we'll say, let's call it 6, right? Let's say there's 6 things in here. We'll build it up, and if we hate it, we'll change it and do it again. It has a threaded rod out the bottom. I want to show you my favorite trick for doing threaded stuff. A little hint. We don't model threaded stuff ever. We steal it from McMaster Carr, and that's completely legitimate. So let's jump into this one. I'm going to just tuck this over here for the time being. In fact, I'm actually going to put it on a layer, so maybe I can turn it on or off if I need to. And if I click on my layer stack and I pick this object and I just right click and I say change object layer, I'm going to double click on this and change the name. That's going to be the images. And then I can turn this on or off, and I can lock it. And I'm just going to lock it so that I don't accidentally, you know, pick it or do something like that. And then let's kind of figure out kind of what we're going to do with this thing. And basically, anything that's round, we're going to do with what? It's going to be a revolve, right? I mean, let's be honest. There's no reason to do it any other way. Or is there? There's another way to do this that we'll talk about. Maybe I'll do this the revolve way to start with, and then we'll talk about the possibilities of doing this a different way. Now, before we jump into this, we need to talk about how to make corners, or how to make transitions in NURBS. And if I start with a single curve, right, and we turn the points on, this has got 2 points, right, which means all I can edit is this, right, or this. That's it, right? I've got no internal structure in here. So if I want to make a corner, corners in NURBS are made in 3 points, right? 1, 2, 3. That's how we make a corner. Now, if we have to make another corner going down, how many points do we need? 1, 2, 3, right? If we're going to make another corner going this way, 2, 3, 1, 2, 3. All right, we're starting to get the drift here. Now we can do this all in one shot, right? It doesn't have to be segments. We can go 1, 2, 3. Now we can steal this point and go 1, 2, 3, and then we can go back up here, and then we can go out here. And each transition, if we look at it, is made up of 3 points. 1, 2, 3 makes this corner. 1, 2, 3 makes this corner. 1, 2, 3 makes this corner. 1, 1, 2, 3 makes this corner, right? Does that make sense? If we wanted to make this sharper, we would start with an anchor point, and then we do 1, 2, 3, drag a line. 1, 2, 3, drag a line. 1, 2, 3, drag a line. 1, 2, 3, right? Corners always have 3 points. They have to. If we want to make them sharper, we pull them closer together. If we want to make it softer, we pull them farther apart. But always 3 points. That is the formula for a corner. Now, knowing that, when we build this part, what do we need? We need, if we look at, let's go back to this. If we look at this curve, and we start saying, okay, there's a little flat here. Maybe it's a flat, maybe it's a round, but there is an obvious corner here, and then there's a dip, which is, we're going to call that a corner, and then it kind of comes back up. We're going to call that a corner, and it comes back over, right? So this shape is going to look like this. Let's call this our flat and say 1, 2, 3. And then I'm going to steal these points, 1, 2, 3. Let's call this our profile. And if I mirror this, and for tangency's sake, if I pick all of these points, notice how there's no handle here? In order for these points to be tangent, they need to be in a straight line. And we can prove that by drawing a straight line. See how these are all lined up? If this point was here, these curves are not tangent. And we can prove this if I pick, and if I run the gcon command, and I pick here and here, these curves are actually G2. And it's saying, I'm getting actually a curvature match off of this, even though strictly speaking it's tangent because it's G0, G1. The G0, G1 points are lined up. But because this is the same curvature going in and out of the curve, it's actually calling, out of the transition, it's actually calling this G2. And I'm not going to get too far down into the weeds with that. But let's call tangent the 0 and 1 point, 0 and 1 point. Let's call this is tangent if these are lined up. Still tangent as long as they're lined up in this direction. Still tangent if they're lined up in this direction. Still tangent if they're this far away. Still tangent if they're very close. As long as these 3 points make a straight line, you're tangent. So with that understood, now we need to do some counting. So for each transition, we need 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So we really need 9 points total if we're calling this one a coincident point. And we can see that if we pick this, it'll say there's 10 curve points because there's 2 stacked up right here. But assuming that this was a single line segment, if I were to join this, if this was a single line segment, this would have 9 points in it. Now, 9 points times 6 dents is going to be what? 9 times 6, right? So if we were to take this and say, and copy this from here, 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. This is how many points that we're going to need. Now, assuming that these points are joined, so if I take this and I join these all up, it'll give us the right point count. Or we could do something silly and just add it. But if I join this all up and we turn the points on and I take these and I do this, it's got 49 points, right? And if we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, right? You're like, wow, he can count. So we need 49 points in order to be able to make this type of shape. So it's a long way to get there. Stay with me. If I take a revolved surface, how many isoparams, because isoparams equals points, right? How many isoparams am I going to need in this revolved direction? The correct answer is 49. What that's going to allow me to do is then revolve this thing, pick the points, and just scale them. And when I scale them, we're going to get this type of shape. Now, so we know we need 49 points in this direction. How many points do we need in this direction? Well, that's a good question. If we were to start up here at this surface, because this is going to be a straight line segment, this is going to be a little arc, right, to get that shape. If we were to start here, there's a round here, right? So we're going to need 1, 2, 3 in order to get this shape. And then there's a corner here, right? So there's going to be 3 more here. And then there's probably going to be 3 more at the bottom. So what's that, 9 now? We're going to probably need 3 more at the bottom here to come up. So that's 12, 13, 14, 15. And then probably a straight line, so 16, 17, 18, 19. We're probably going to need 19 or 20 to get this shape because I'm going to need enough isoparams in here to be able to grab points in this area and pull them in. So let's give it a shot. Let's just draw this thing starting. I'm going to start up here. I want to give myself enough space to make the excuse me, make the arc. So I'm going to start here and say 1, 2, 3 to get my big roundy. And then I'm going to turn the corner and then I'm going to just draw it as a marshmallow for now because we can always rebuild. And I like to do things as simply as possible. And I'm going to bring this over to here, something like that. And then I'm going to add a line up here for this piece. And then I'm going to add the little hosel down here and something like that. That might be really thick. Something like this. And then I'm going to take this, and this is a little trick I like to use. I'm going to just mirror this piece over. And I know this is centered around the center line. And I'm going to use a 3-point arc. And I'm going to go from here to here. I know this is centered. And now my center point, I can determine how much arc I get out of this thing. The other thing that I might want to do is I might want to mirror this just to see how fat this thing is. And this is looking like massively fat. Like this is kind of normal, you know, a little narrower. So let's edit this. I'm going to turn the points on and I'm going to just pull this in a little bit, make this a little narrower. Maybe it needs to be a little taller to kind of get the proportion that we're looking at. And granted, I don't have enough points in here to make this shape, right? And I don't want to just spin this shape because I need these pieces out here. So maybe what we're going to do is, first of all, I'm going to make myself a center line and get rid of all of this because I don't need it anymore. That was just for reference. I'm going to take all this stuff and join it. Actually, I'm going to bring this and close it too because I want this thing to be closed. I'm going to take all this stuff and join it. And then let's go ahead and just revolve it. And let's see where we are. Let's just take a look. So we're going to come down here and just make a simple revolve. And we're going to make it full circle. So we're going to just type U, enter. If you don't know this, if you look in the command line, see how each letter, see how the F is underlined in deformable and the U is underlined and the A is underlined and the S is underlined. If you type U and hit enter, it invokes that command out of the command line. So it's a really fast way. You don't have to go up and click. You can just look and say, boop, and get it to go. All right, so I'm going to hide the image for now because get it out of the way. Let's take a look at what we've got. So this kind of gets us where we need to go, right? So assuming that the outer extents of this thing are basically here, now we need to get the internal stuff, right? So let's explode this. Because this is a poly surface, we can't turn points on for poly surfaces. Wah, wah, can't do that. So let's explode this and get it back to its original surface. And I'm going to hide everything. By the way, I have a hotkey set up for the isolate command. If you don't know the isolate command, if you pick this and type isolate, I'm working in version 6, by the way, and hit that, it gets rid of everything except what you picked, which is super useful if you're like me and can't stand clutter on the screen. I gotta take coffee. Hang on just a second. All right. So we've got this thing. Let's turn the points on. And you can see if I select any of this, pick this, cell U. Cell U is the command to select all the points in the U direction. How many points do we have going on here, right? And I can do that by typing what? And, no? Cell U. It should tell me how many points they're selected. It doesn't. What doesn't work on that? Come on. Nope. Got to be just the object. All right. Never mind. So let's do this. I want to drag select them. I want to be able to see how many points there are here. I could count, but that's, I'm lazy. So there's 8 surface points here. And we decided we needed how many? We needed 49, right? So that puts us in a position where we have to rebuild this thing. So let's rebuild it. And we know that in the U direction and in the V direction, right, it says 8 and 8. So in the U direction, which we've already determined is this way, we need 49. And we can preview it and say that. And then how many points did we decide we needed in this direction? I think we decided we needed like, what, 1, 2, 3, 4, 5, 6, maybe 7, 8, 9, 10, 11, 12, 13, 14, 15. Let's say like 15. Let's try 15 and just see what we get. And we want to change this to 3 and 3. And let's preview it. That's about what we're going to want, right? And look at this. Look at all these wonderful points that we have to play with. Now, here's the trick. We need to be able to select these points in order to be able to modify them in a way that makes sense. And because there's 49, right, we want to pick these, and we want to end up with 6 total. And I wish I could tell you that there was a really slick way of doing this, but I think what I'm going to do is I'm going to pick all of these. And then starting at the center line, I'm just going to control drag and pick, get rid of that row. And then let's say it's 5 points from there, right? Let's see, 1, 2, 3, 4, 5, 6. Let's 49. Let's see. Let's go. I could do math, but that's not my strong point, clearly. So let's pick this. Now, just to show you what we're going to try and do is, and I'm going to deselect everything else, because we could, the other way that we could do this is we could just model a section and then mirror it, which might be the way that we end up doing it. Like I said, I don't practice this stuff. I have to figure it out along the way. So if we grab this and I were to scale these points inward, right, then I would get, and if we do this scale, and I set this, actually let's do it with the gumball, because I like using gumball instead. So let's relocate the gumball. Gumball relocate is the command. And the gumball origin is going to be in the center of this object, if I can get it to snap to the center. And if it won't find the center, then we'll make it find the center by doing this. Actually, it's the origin is the center, isn't it? That would make sense. So let's grab this again. Let's grab these. Make sure that we're getting the same amount on either side of the center line. And let's get rid of these. Yeah, because this is my corner, right? 1, 2, 3. These points here can determine how sharp this corner is. These points up here determine more or less how sharp this corner is. So I kind of want to leave this row and this row alone. So let's do this. And I'm using Control to deselect. And let's just make sure that on the same side of that we have an even number, right? 1, 2, 3, 4, 5, 6. And if I get rid of those down there and I relocate the gumball to 0, that's going to put me right in the center of this object. Now, if I shift scale this, look what happens. I get my really nice transition. Now, am I stuck with this? No, because I can do things like this. I can come in here and grab these points. And if I was really trying to be fancy, I would try to do all this at the same time. But if I pull this up, see how this affects that corner up there? And if I grab these, this might be easier to do in wireframe, but it's harder to visualize for you guys for the webinar. So I want to just keep doing it in shaded view. These control this down here. This row, remember we talked about that curve. If we pull them apart, it gets tighter. If we pull them closer together, they get sharper. So this row, and because this is symmetrical, I want to do this at the same time using scale. The gumball is a really great way to maintain your symmetry, by the way. So if I'm messing with this row and this row, let's make sure I got the right one. No, I don't. Let's make sure. Let's do this. Doop. It's this row that we want to mess with. So I'm shift clicking each one of these to add. Sometimes the gumball handle gets in the way and you have to wiggle it a little bit to get around it. And then I'm going to scale this in this direction. See, I can make that really sharp or really soft. So just by manipulating these points, I can determine, you know, how soft or how sharp I want this to be. And if I pick these things and now mess with them, I can come in and design this thing in 3D. If I pull it up, let's make sure we get everybody. That one's hiding behind the scale handle. If I pull this up, see how that softens? And if I pull it down, see how it sharpens? So I can kind of tune this thing to get it how I want, and then decide, you know, where I want all this stuff to fall. And so just by dragging some points around, I get a lot of ability to be able to determine where this stuff goes. Now, here's an interesting thing that just happened. See how I grabbed these points, but I missed this one? Watch this. If I grab this guy, if my gumball is set to snappy dragging, it will respect O snaps, meaning that I can just drag it up, hold down my O snap. I run my O snaps disabled, by the way, and the Alt key is the temporary enable disable. So as I'm dragging, if I hold down Alt, it'll snap together. Now another cool trick is if, let's say, this guy is out of line with these guys, I can scale these to 0 in one direction, which will flatten them and then snap it back into line with the other ones. It's a nice little modification trick. Excuse me. All right, so let's shade this and see, do we like that? Is it the right shape? Is it too deep? Is it like maybe these guys, we want to punch them in a little bit? And do this in wireframe so I can see what I'm doing. Got to catch the ones that are hidden behind the gumball handle. And so because we know how the numbers work, right, we can modify this stuff and know exactly what we're doing. So now this is going to be dished in. Now it's going to be pulled out. And we can play with it and really get something, a nice little pocket in there. Now, since we know what this is like, right, we could go ahead and just model this in all the way around. Or we could be super lazy and just scale that, or just do an array. So let's take this and let's make a array, polar array at 0. We want 7 items, right? Is that what we talked about? Or no, 6 items. We wanted 6 items. And we're going to polar array this thing. Now, this isn't in the right orientation, so I'm going to take all of this stuff, actually, because I did it with history on. See this? I can take this guy, and I can revolve it, or I can rotate it, sorry, out here like this, and I'll just snap it to that point. And then all the rest of them are going to update, and that's not quite what I wanted. Actually, if I were to revolve, if I were to do 12 of these and then make the one that's in the center, let's do that. Let's be really slick about this. Otherwise we have to go and like figure stuff out. Who's got time for that? So let's array this polar and let's do 12. And what 12 is going to do is it's going to give us, this is the center of this thing, and these two are the ins and the outs. And you know, maybe these points, see how these points aren't exactly lined up at the center? So maybe what I need to do is I need to take this and I need to rotate to snap to here, and then see how that's centered now. If I'm calling this the center of my dip, and I could probably be fancy and figure that out, although it looks like it's not. Actually, it looks like what I need to do is be right between these two, isn't it? Because it's that and that over there. So let's do that. Let's rotate, and I'm going to use the between switch. Watch this. I'm going to hit P, enter, and I'm going to place it between these two. Oop, moved it, sorry. Center of rotation, this is the first place. The second place is going to be between here and here. So now that's centered. So I can take this and trim everything else away. People are like, you weren't kidding about not rehearsing these. Yeah, I'm not. And I've got my one little segment. Now, if I go back to my front view and I array this around 0 6 times, it worked. No one's happier than me. We get this. Now we join it. If we're living right, this is all going to join up with no pink. We bring back the rest of our stuff. This joins up. This joins up. Let's hide everything else. Isolate. And then let's take a look at it. What else do we need to do to this thing? Let's break this edge, and I'm going to just do that with a fillet. And actually, I'm not going to use a fillet. If you right-click on this, you're going to get blend edges. The blend edges is different than fillet. Fillet is a circular, it just takes a circle and shoves it in the corner, right? Doesn't have any respect to tangency or anything like that. In fact, fillets are usually at best G1, most often G0. Blend, on the other hand, if I right click this, it actually does it by continuity. Oops, got a little edge there. I'm going to chain the edges so I get everything. Boop. And then the radius on this is 1 unit. I don't know if you can see that. It's huge. See how this is red? I don't know if you can see that, but see how the indicator is red? That means it's too big. It's not going to fit. So I'm going to drag this. See how it just changed to white? And then I'm going to preview it and decide whether I like that or not. And I think in this case, I'm actually going to buy off on that and say, yes, I like that. So I'm going to right click to accept. And that gives us a nice soft edge. We can even go one step further. I'm assuming that this is going to be like a logo insert or something like that. So maybe what this even needs to have is a little, this needs to be a pocket with a secondary little lens or something like that, which we can do if we break this out and we take this and we pick it and we start dragging and hold down the control key. It actually extrudes it. Let me isolate that and just show you again. If you don't use this trick, by the way, pick on it, start dragging, hold down control. See that line that shows up? Boop. We just extruded that thing. Now, the cool part of this is I can take this and break this off, bring this back and hide that. And you can see this is the pocket that we built. And maybe there's a microscopic little fillet on this because that's how the world works. If we're really getting fussy, there is no such thing as a 100% short corner or 100% sharp corner. We bring this lens back. I'm going to scale this, shift click, 0.99. Just a teeny tiny bit, maybe not even that much. Shift click 0.999. Just enough so that I have a little clearance. Maybe that's not enough. Let's say 0.995. See how it just gave me a tiny little bit of breathing room in there? Then I'll go, let's go to the right-hand view. I'm going to do the same thing I did before. I'm going to start dragging and then hold down shift. And I'm going to compare it to that. I'm going to just kind of bring it so that it just kisses that. Because I want to be able to, like, maybe I want to print this thing. Maybe I want to print this thing in plastic and I want to print this in clear. And I want to have that be something that I could put a label or something. This is going to be clear. And then I take this and it sticks in here like this. And it's got a little logo with a little clear thing over it. Okay? Now, the last thing we're going to do, I'm going to delete the curves for now. And usually what I do if I'm working on a client project, I make a curves layer and I just dump everything here. And the reason I do that is because if your clients are anything like mine, they say, we love it, except we would like you to change everything. And so if I have my curves, it makes it easy to do. And we'll go from there. Now, I want to break this edge. I don't like that. So I'm going to go and let's blend this thing. I'm going to chain edges. Gets everything. I'm going to, whoa. Since I have preview on, see how that's like crazy? I don't want that. So let's bring this down. There we go. That's much better. Preview's nice because it's non-destructive. You can try it. See what it's doing. And then I'm going to break this edge too. And that's obviously way too big. So I'm going to drag this down. Now, if I was doing this for a production piece, I would actually pay attention to what these numbers are. And let me see if I can do this in wireframe so you can actually see this. See how this number, the numbers as I move up, you can read what the numbers are. And if I look visually and say, that's about the right fillet. If this was like up here, right? And it was .037 was what I decided I wanted, I wouldn't do it at .037 because .037, if this were to be CNC machined, I would have to either go in with a .35 tool, which would be a common size, and do a couple of passes through here, or I would have to get a custom tool made, which the tool maker is going to hate you for, a .037 tool to cut that in a single pass. So let's be easy on our tool makers, and let's say I'm just going to push that to .03. That is a common tool size, and I know that when I send this to my tool maker, he's not going to go, what are you kidding me? There's a .0373216 radius fillet in here, and he's either going to do it and charge you for the custom bit, which is going to make your job more expensive, or he's going to call you and call you bad names, which is usually what tool makers do. No disrespect, that's well within their right to abuse designers. All right, so we've got our kind of knob made here. Now let's do the threaded part. This is one of my favorite tricks of all time. I found this a couple years ago when I was doing a job, and I had to have a bunch of threaded stuff. There's a website, a company here in the U.S. for those of you who are outside of the country and maybe have not heard of these guys. They're in Elmhurst, Illinois, founded in 1901. It's a privately held company called McMaster-Carr. If you click on this, it brings you to the holy grail of all things fastener. And if I go to threaded rods and I say threaded rods here, and I say, who cares? Let's just go with this. And I want this to be, let's go back one because I want it to be metric. Let's go metric. I want this to be a metric threaded rod, and I want this to be a, I have no idea how big this thing is. Let's find out. I probably built this massively, but let's go from here to here. So it's 0.39. So it's like it's like 0.8. I think this is inches. Let's make sure. Tools options. Things you check beforehand. Yeah, this is inches. So like 0.8 is about the size of this thing. And if I were to, so 0.8 of an inch, somewhere in there. Let's see what a diameter of 10 millimeters looks like. That is probably a little small, so let's see what a diameter of 12 millimeters looks like. That'll probably do it. So we're looking for like an M12 bolt or a threaded rod. So let's go to M12, and let's say it's going to be 300 millimeters long. It actually doesn't really matter. Let's get a longer one, say 500 millimeters. Here's where the magic happens. Product detail. Click. Look at this. What format would you like a 3D model of this bolt in? I would like it in 3D step, please. Save. Download. Show in folder. Drag into model. Import. Ta-da! We now have, and the cool thing about this is these are really good models. If I look at this thing, it's got no naked edges, no non-manifold. And if I take this thing and I can just go derp like that, take this, and I'm going to Boolean subtract it because that's the way this thing would be made in real life. So now here's the cool thing. This now has perfect M12 threaded rod threads in it. So I can print this thing. I can go to McMaster-Carr and buy this piece of hardware. When the piece of hardware comes in the mail and this comes out of the printer, I run an M12 tap through this just to clean the threads up from the printer. This will screw in with your fingers. It works perfectly. And you will never model threads again. You're welcome. Same thing with nuts, bolts, inserts. If you need to, I downloaded a pile of these things, so I actually have threaded rods that I use as cutters. Anytime I need threads in a part, I just take one of these, jam it in there, boolean it out, and then when the print comes out, I just run a tap through everything, and the stuff screws together with your fingers. It's brilliant, and I don't mind claiming it as my own. All right. How are we doing so far? Everybody happy? Any questions? By the way, these sessions are meant to be interactive, so please, 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 if you haven't been to one of these before, I highly encourage comments from the peanut gallery. Feel free to taunt, ask questions, point out things that I'm doing that are stupid, make fun of me because you're watching me to try to do math live in front of an audience. It's the reason I went to art school, people. All right, we cool with that one? So we're gonna call that one done. Woo, 9:47, we knocked that one out quick. So let's change the object here and let's hide it. Let's bring our images back. And I'm gonna hide that one. And let's stick everything on this layer. All right, what do we wanna make next? Should we make a super easy one? This one's pretty easy. And the reason I like this one is because it's got a domed surface on it. So let's build this one next, and then I'll let you vote on which one you want to go from there. Any questions so far? Questions, comments, taunts? So this one is actually pretty easy. We can do, this is fairly flat. I'm reading that as fairly flat or poorly drawn. Always have to decide. This is fairly flat. This has a fairly sharp angle on it, but this has a little round to it. So what we're going to do is we're actually going to build this, and the round first, and then we'll do trims, and then we'll extrude the whole thing. We might even do a shell to assume this is an injection molded part. This one would probably be a cast part. I actually have an exercise bike that has a knob like this I was looking at it the other day thinking, I wonder how you build that. Now we know. So let's look at this thing. And we might even throw the shell tool on here and do some ribbing and stuff like that. So let's do that a little bit more interesting, and then maybe we'll jump into this one, and then you guys, I'll let you pick which one you want to do next. So this one, let's start with a center line. So I'm going to start at 0, and I'm going to come out, and then I'm going to come up. And if I was going to be sassy, I could even do a grid snap on this. And then let's do the same trick we did before. I'm going to mirror this. And the only reason I'm doing that is because I want to use a 3-point curve. I could do this with a circle too, but I like 3-point curve. It's always been good to me. So let's snap this. We know the center is right here. And then let's take this thing and let's just shift drag to scale it out. And when we shift drag to scale it, we know it's going symmetrically. And then let's do this, trim it. I can get rid of this because I don't need it anymore. And that's our nice little dome shape. So let's take this and join it up. Go to the perspective view. Let's revolve it. 0. I'm going to use the end of the revolve axis. Press enter to use the C plane Z. That's what I want. C plane Z, full circle, you enter, and there's our shape, except I revolved it in the wrong direction. Derp. I drew it in the top view and then I revolved it in the top view, so that doesn't make any sense. So watch this. If I take this guy and I relocate the gumball to here and I rotate it 90 degrees, because I did it with history on, watch this. Boop, now it behaves. That's the right direction. All right, now we're going to do most of this without any modeling tools. Check this out. Shift, Control, click. That selects the edge. That's called a sub-object selection. If you haven't done this, you can Shift Object select parts of a poly surface. This is the whole poly surface. Shift object select, select. I can delete, shift with the sub object. I can edit with sub object. I can copy by tapping Alt. All sorts of stuff with sub object. These are gumball magic tricks. All right. There's a really, really great video by Brian James. If you Google Brian James Hello Gumball, it'll tell you there's a great video that he did about all this stuff. So shift, control, click. See this little dot in version 6? If you don't have this, if you're using version 5, this is just control drag, or drag control, sorry. In 6, just click the dot and drag, and it will extrude that edge. I'm going to join this up, cap, and then I'm going to shell this thing. Now, everybody gets all excited when I show the shell command because they're like, oh my God, I didn't know Rhino had a shell command. It does, but calm down. It's not amazing. It works great for simple stuff, but if you want to do like a 2000 surface model and shell that, I got news for you. You're going to get something, but you're going to have to do a lot of repair to it. And that's fine because Rhino, when Rhino fails, it at least fails and gives you something. Right? It's like that old Monty Python sketch where the arrow hits the messenger's chest and he goes, "Message for you, sir," and then dies. That's what Rhino does, right? If you say shell on something super complicated, it's going to go, "Bah! Here's your shell," and then it's going to die, right? And then you're going to have to go in and actually fix it, but you'll have something to start with. So let's shell this. This should work. I don't want a thickness of 1. I want a thickness of like 0.15. Let's make it a little burly. And then this is the face I want to get rid of. And it shelled it pretty effectively. And I'm pretty happy with that. Now, what this does is this gives me a perfect situation where I can shift, control, click, click, start dragging, hold down control. Ooh, it doesn't like it on a poly surface. All right, fine. Merge all faces. When I merged all faces, it took this from 2 surfaces and made it into 1, because what merge all faces does is it goes and it finds everything that's a coplanar surface. See this? This is 2 surfaces, but they're coplanar. 2 surfaces, but they're coplanar. Merge all faces. Now, one, well, that one didn't, but this one did. So now I can control shift click. See the dot comes back? Beep. There's my center section. Now, the drawing shows this tapered. So let's taper it. Shift, control, click, shift, drag, and tapered. Now, I probably jumped the gun here because I got excited about showing shell and I jumped ahead. We forgot to put these in. So let's go back. Control Z, 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 Z. Let's put these in, and I'm going to just do that with a circle. I'm going to snap it to here, shift drag, drag it down to about here, transform, array, polar, and how many are on here? 1, 2, 3, 4, 5, 6. All right, now let's take a look and see whether this makes sense. Now this is tiny. I don't like that. So I'm going to pick the original one, which is this one, because we did it with record history. And I'm going to drag this away a little bit. See how it's opening that up because they all updated? And maybe I make it a little wider. I'm happy with that. So let's do, I could wire cut this, but then I'd have to wire cut, wire cut, wire cut, wire cut, wire cut, wire cut. Watch this. If I grab all my curves, curve Boolean, if you haven't used this, you should. Delete input all. Click out here and in here. And it makes one big curve that I can pull up and then extrude. And then I can grab this thing and I can cap it. And it didn't make the cap the way I wanted it to make, so I'm going to do it with the planar surface. And I'm making myself a giant cookie cutter. Making myself a Boolean object. Not you. No one invited you to this party. All right. It worked down there. These might not be lined up. They are. So let's see. Okay. You're misbehaving. So why did it do that? I don't know, to be honest with you. It shouldn't. It should find its way. But it didn't. So we won't be too sad about it. We'll just trim it and do it manually. Close poly surface. Boolean subtract this from that. Delete. There's our object. So much easier than trying to do all that other nonsense. Now let's show it. Boop. Now let's merge all faces. Now let's Control-Shift-Click, drag, Control-Shift-Click, Shift Scale, and we're good. Let's bring this guy back. Let's steal this threaded rod. Let's drag it to the center. And there's that knob. Now, should we put some ribbing on this? Why not? Let's do that. So let's extract this object. And I'm going to just cap it. Seems counterintuitive, but I'm going to cap it because what that's going to allow me to do is I can pull isocurves from this. Let's do, I want an isocurve, not an edge. Pull an isocurve using this. And I'm going to put one like here. I should get nutty and measure this, but I'm not gonna. See where I'm heading at with this? Shift drag, click, shift drag. Trim these together. Trim that together. And I'm going to explode this now. And I'm going to join up these curves, and I'm going to just trim this. I'm going to just make it easy on myself. Now, you might notice that trimming misbehaves if you do it in 3D space. The reason for that is it's trying to project to the construction plane. So the best way to do this actually, and it worked out here, I got kind of lucky that it worked out like that. But if it doesn't, like if you try and trim something and it goes crazy in 3D space, the fix for that is to use this set C-plane to view. So watch this. If I draw a curve through here like this, right, and it seems to make sense, I should just be able to trim right through that thing, right? My dog's gonna bark, sorry. I've got a cleaning person coming. I'm gonna stop for just a second, let her quit barking so I can edit this out of the video. The second I start up again, she's gonna bark again. All right, so if I have a curve through this thing, and I try and trim this, watch what happens. See how it doesn't know what to do? If I take the C-plane and I change it to this eyeball icon, now the C-plane is what I'm looking at. Now when I trim, it kind of knows what it's looking for. My rule, for the most part, and I broke my rule when I did this, but my rule for the most part is always trim in orthogonal space. Okay, so let's just knit this back together. I'm going to join these. We're going to go to the top view, transform array polar. We're going to do 4 of these. And I'm going to pick all of this. And trim. This works best if the thing's exploded, by the way. Join that. I'm going to knock the top off because we don't need it anymore. It served its purpose. Bring this back, hide this guy. Now, if I join this, there's going to be openings, right? We look at show edges. You can see it's joined here, but it's open here. We'll just run cap. Cap's going to find those and fill them in. Now, if I bring my threaded rod back, you can see that that's not going to be cool, right? So let's go to the bottom view. And I'm going to just make a boss. Start at 0. I'm going to just make a boss that contains that. Go back to the front view. Snap it to there. And I'm just going to Boolean this together. Boolean failed. All right, fine. Now, why did the Boolean fail? The Boolean failed because Booleans do not like coplanar surfaces. They don't like this situation. So how do I fix that? Well, I'm going to just take this and make it a little taller. And you say, well, that's not what you want. I know, calm down. So now the Boolean worked. Now I simply just go and trim this off. And cap. And if I want to clean this up, merge all faces, bring this back, Boolean subtract. Ta-da! Now we can go and fillet this and do all sorts of stuff like that if we want. Ooh, I got a little crazy here. Watch this. I'm going to delete these two, and I'm just going to cap. Merge all faces, and it's all back to good. Okay, I stuck that boss up too far. I poked through there. All right, let me check. Question: is there a way you can select the point control point without selecting the surface accidentally? There is an option in here when you pick something that turns the points on, and it is, and I'm not going to remember where it is, but mouse. Yeah. Turn on control points when selecting a curve, light, or annotation. Allow selecting objects with points on. If you shut this off, when the points are on, you can only select points. There's also filters. I don't know if you've messed with filters. Selection filter, you can turn on just control points. If I shift click this, it's only control points that'll allow me to be selected. So now I can't select anything other than control points. If I shift click it, it's a one shot and it goes back to what it was. Or I can go and manually turn all this off. Okay, so if you're doing a lot of point editing, just go to the selection filter, only turn on control points, and then I think it's alt click. No, one of them. Okay, so we just do, yeah, so just turn everything off except for control points, and then you can only get the control points. All right, so if we wanted to fillet this thing up, we could go ahead and do that. In this case, I'd use blend, and I am going to drag select all of this stuff, and then deselect. I don't need these. Actually, you know what? Let's do the whole part. That'll make it look like it was made in SolidWorks. Let's do the entire part. And I'm going to do this as a much, I added way too much stuff. Let me do this, let me kill this. Set all, let's do 0.02. Actually, I'm going to kill that because you know why? It selected the threads, and I do not want the threads selected. So I'm going to do this again, and then I'm going to drag, Control deselect that, and then Shift drag. Yeah, I would not want to throw the entire threaded portion of this model at the fileter. Sorry. It's my daily check-in with my business partner. Does he come to the webinar? No. No, he doesn't. All right. I'm going to run these as well just to have them. I think that's everything. Let's see if that'll go. Looks like it. Boop. And because we use the same size fillet, our tool maker will like us because they can just use a 0.02 tool to go in and clean this all up, and it'll be good to go. All right. All right, 10:07. We got about an hour, depending on how much time you want to spend, and you're welcome to leave any time. I hope you don't, but you can. Is there a way I can select the? Yes, Kamal, does that or Hamam, does that answer your question about the surfaces? Any other questions? All right, let's build another one. And I'm going to hide this. Oop, wait a minute. Did I see some naked surfaces here? I do. Let's fix that. See this up here? That's a little messy. All right, not quite done with this guy yet. And the way that I'm going to fix this is I'm going to pull this out. And I'm going to pull this out. And I'm going to just blend between here and here. That's going to give me a curve. And I'm going to trim. And see how that trim didn't work correctly? Because I'm trying to do it in 3D space. So let's go to the top view. It would help if I finished it. Actually, you know what? I'm not going to use a blend. I'm going to use an isoparam. So let's pull an isoparam out of this. Hit the T key. I'm going to snap it to here. Same thing over here. Doesn't do any good to send out a part if it's got holes in it. All right, so let's do that. I'm not going to do the whole thing. I'll just fix this part so you can see what's happening. This is how you would fix it though. Okay, I'm going to hide that curve. I'm going to just blend this edge just to make it easy. Oh my goodness. Sorry. And I'm going to just do this as tangency. And I'm going to alt drag this handle and snap it here. Alt drag this handle and snap it there. Same thing over here. Alt drag. Alt drag. That straightens out the ends of this thing. And then I'm going to just bump these a little bit. See how those redistributed themselves? Say OK. And then I'll go in here just with a four-sided surface. 1, 2, 3, 4. Same thing over here. 1, 2, 3. Nope. Join those up. And that's what I would do for the rest of these. Actually, what I'd probably do is I'd probably take this thing and copy it around 4 times and then just trim it in. All right. But we want to make sure that we don't have any pink. No pink when we send out a part. So I would go ahead and spin this around, make sure that I have all those fixes. But I'm not going to bore you by fixing all 4 of them at the same time. Make sure that you check this stuff, by the way. Make sure that you check naked edges. Make sure that you check cell open polysurf. See how that lights up? That tells you it's not watertight. If it's not watertight, don't send it to someone. Don't send it to a printer. Don't send it to an engineer. Don't send it to Asia. Don't send it to a manufacturer. Don't send it to a machine shop because the part will fail. Make sure that your stuff is watertight. Okay. You can also use check. Check says it's valid. That's great. You can also use what. What says open polysurface. Open polysurface means do not send it. Fix it. Make sure that your surfaces are closed before they go out. All right, so you would want to apply this fix all the way around. Okay, let's build a new one. Is this helpful? Are we enjoying this? Let's build this guy because this one is like seems super complicated. It's actually really, really easy, and there's a neat way to do it. I'm going to start with an oval. And I'm going to drag, extrude. I'm going to shift, control, drag to get that edge. Shift, drag to taper that a little bit. I'm going to mute for a second and clear my voice. My throat is frogging up on me. Hang on just a second. All right, we're back, and it doesn't sound like I'm drowning anymore. Okay, so the cool way to do this, right? Normally when you do rounded stuff, you start with the rounded thing first, right? Normally if I was going to build this, what I would do is I would start with a sphere. I would turn on the control points. I'd actually rebuild this because it has to be editable. And I would do, I don't know, 10, 10, 3 and 3, and I would edit this thing, and then I would pull points and get my shape, right? And then I'd hack it off and then extrude off of it, right? That's normally how you build rounded stuff, is you start with the rounded thing first. Instead of starting with the thing and trying to round the end, you start with the round thing and build off of it. In this case, I'm going to give myself a couple of reference points. One here and one here. Doesn't matter. Now, to do this correctly, make sure that you have history turned on. Always record history, update children. And then we're going to use the patch tool. And the patch tool is kind of cool. So I'm going to, the edge of this thing and these 2 points, we're going to use as reference and run it. And just for now, I'm going to do this at 10 and 10 and a stiffness of 1, automatic tangency, automatic trim, and preview. Woo! That's crazy. Let's try this again. I think I grabbed the curve instead of there we go. That's better. So now check this out. We've got a really beautiful thing here, right? A really beautiful part. And because this is history enabled, I believe patch is history enabled. If I scale this, I can now start kind of sculpting with it a little bit. But check this out. The points are also history enabled. Look at that. So is this one. Look at how cool that is. It's like some crazy Japanese toilet or a button. Look at that. I can even take this thing and pull it over like this, and it switches. Now, here's the problem with this. If I take this and try and join it, it may or may not join. It's like a game show. Will it join? Now, there's a really simple solution to this. You just duplicate this curve, get rid of that, and use loft between the two. A lot of people don't know this. Loft has a tangency. And we can even rebuild this. And let's refit it. There we go. Loft has tangency. I don't know if you can see that. See that little wiggle in the isoparams? It's actually changing that to be tangent. Now if I join this, it joins up, and you get a really beautiful part. Now, let's say this piece was critical. You couldn't modify this. We're going to do what's called a pipe trim. And a pipe trim is I just run a pipe around the edge. Not that big. Come on, settle down. I just run a pipe around here. And what it does is it makes a really nice, even trimming object that I can then trim both of these with. Delete it. Then I can come in here and simply just use a blend. I'm going to chain all my edges together. And I can do this with tangency. I know this is joined now. If I emap this, cool, huh? Do that. Just a little something going on in here. So maybe what I need to do is I haven't given this enough room to run. So what I'll do is I'll actually trim this down here and blend a little farther down. If your blends start to bunch up on each other, it means you haven't given them enough space. That's better. It's still a little, see that joint here? See how that's folding a little right there? So maybe I need to go farther. Let's do this, split with isoparam. Let's split it way down here. And let's blend all the way. Maybe we add a shape just to make sure that we have enough control there. Emap is cool, by the way. It's a nice way to visualize. That's better. Now we've got no bunching. Cool. So really nice way to iterate. By the way, I have actually built files where I've saved stuff like this out. I had a cell phone project I was doing years ago where it had to have all these crazy buttons on it. And so I made one of these and saved it into a file. And then I brought it into the file, 4 or 5 of them at a time, and then messed with it with history to do all the stuff that I want. So let's cap this. If I wanted to go crazy, I could try, let's try shelling it. I'm going to go 0.08 thickness on this. I don't know if it'll shell, but let's see. Looks like it did. Hooray! Let me show you a trick. Let's say this didn't shell. Let me show you a cool trick here. Start with an open surface. If you're throwing this through a printer and you need something that's wall thickness, mesh it at a fairly high level. Let's say the maximum edge on this is 0.1. Okay, take the mesh. This is an open mesh, single wall thickness. If you threw this through a printer, it would fail. Offset mesh. Check this. We want to go in, and we want to go 0.08, and we want this to be solid. Doop. And I'm going to explode it just to realign the normals. and we are going to unify mesh normals. And we've got a shelled wall thickness part. I don't know why it's not rendering correctly. Oh, it's because there's two meshes in there. There we go. Meshes, the normals were turned inside out. So now I've got a wall thickness part. If you have a closed piece, by the way, that works also with a closed piece, but you just have to put a little hole in it. So if I try to do this with a sphere, it doesn't work. I'm going deep into my bag of tricks now. Everybody's like, wait a minute, this isn't a knob. So if I mesh this and I offset the mesh, and I say solid, it's gonna do it, right? There's an inside mesh and an outside mesh. The problem is when the printer sees this, it's gonna see this mesh as an inside mesh and this is an outside mesh. You actually have to connect them. Rhino recognizes this, your printer won't. So what you have to do is you just have to knock a tiny little hole through this thing. So let's do something like this. And it doesn't have to be both sides, I'm just doing it because it's lazy. But if I do this, now I mesh offset, do solid. Now what you'll see is this thing is now connected. There we go. Got to make sure your normals are pointed out. And the way to check that, by the way, is to go over here. So there's two meshes stacked on top of each other. I don't want that. Let's do this. See how this one is pointed inside? So we want to flip it. Boop. Now it renders correctly. If it doesn't render correctly on the screen, fix it. Don't send it to your printer. If it doesn't look right on your screen, fix it. So now those two edges are connected. So now your printer will see this. And then you just put a little dot of super glue on there and sand it off. All right. Alrighty. 1023. How are we doing? Do you want to see another one, or are you bored to tears? Oh God, everybody's died. I've killed you all with boredom. Another one. Okay. Let's see. What would be an interesting one to do? Let's do this guy right here, because this actually has an interesting little concept that we can use with a deformer, and then that probably will be the end, unless you want to see a different one. But let's do this guy right here. So this one is kind of cool because what we have here, if we look at this, we've got a base object, we've got an object that's offset up off of that, and then we've got a depression that's tangent here, but has a little blend into this corner here. And there's a formula for doing this stuff. So what we'll do is we'll start with a simple surface, right? We'll start with just something like this, and I'm going to hide the image. That way you can't see when I cheat. And let's even add a little shape to this. Let's say it's like a console of a car or something like that. Everything's a car part as far as I'm concerned. All right. So what we want to do is we want to establish what our original button is, and then establish what the inside is. And the way that we do this is we draw the original shape. And let me center this just so that let me get this centered, because I want to, actually, let's do this. There we go. I want to be able to use symmetry. So I'm going to start at 0 and I'm going to start drawing out. And here's my corner. Actually, I don't want to use corners. I want straight lines. So I'm going to start at 0 and come out here. Take this and move it up like that. And I'm going to come straight back like this. And then I'm going to go to 0. Turn my points on and snap it back flat. And I'm going to mirror this. There's an easier way to do this. I don't know why I did it like that, but that's our original shape. And actually, let's make it more complicated. That's too. I'm letting myself off the hook too easily. So let's do this. Let's call this our original shape. This will be our outside of our button. Okay. Then I'm going to copy these and I'm going to scale it down. And then I'm going to turn the points on and I'm going to pull these points over here. Now, this is going to be the surface of my button. This is going to be the blend back to the original base shape. So I want to make sure that I have enough room to do that. So I'm going to play with this until I get basically what I want. And if the button is completely raised, this would be inside this shape. If it's tangent, and I'll make it tangent here just because that's a little harder to do. And then we'll put a secondary tangency inside this thing. So I'm going to take this now and copy it again. Shift drag. Copy it again and shift drag. And then these points, I want to be lined up with here. And then I'm going to just draw a straight line connecting that all out. So that is, and actually these should be, this is the formula for doing these things. Outside curve, inside curve, and then this is the outside curve, inside curve. So this is going to be the surface of our button. This is going to be the part that lowers down. This is going to be a blend. This is going to be a blend. So what we do is we take this entire surface and we split it using all of these curves. And what this does is this gives us a surface here. We're going to delete it. Gives us a surface here. We're going to delete. And then what we're going to do is we're going to take this surface and we're going to turn its points on. And we're going to take it and we're going to pull this up like this, right? And we've pulled it a little bit too far away from this. So let's do it a different way. Let's take this and let's bend it, but let's bend the points. So I'm going to take these 2 points. I'm going to bend them, but I'm going to bend them starting about here because I don't want to disturb this relationship. Oops, I've been in the wrong direction. Yeah, let's see. So front is that direction. Right, that's the direction I want to bend it in. So let's bend these points. Starting out here, I want to get far. This is the connection point I don't want to break. So I'm going to start like out here. I'm going to bend this up. And what that does is that raises this thing, but it maintains this connection as much as possible. And in this case, it looks like it's still kind of pulled away. So we may have to deal with that. So let's do gumball relocate. Let's put it here and let's snap that to that edge. That may be close enough. We may have to fix that, but we'll get there. Then I'm going to take this guy, gumball relocate here, and then I'm going to turn his points on. Actually, you know what? Let me back up a second. I know how to make this work better. Let's shrink this trim surface. What that's going to do is that's going to keep these points much more in line. So this connection is going to maintain itself. See how these points are now right on the edge? So now if I take these points, I go to the right-hand view, bend. Now why am I bending the points and not the surface? If I bend the surface, it rebuilds and gets really complicated. See how it added all these extra isoparams? It's not crazy here, but if I went a big bend, it would do a lot. If I bend the points, it doesn't. And I'm going to leave these points alone. And I'm going to just bend from here to here. Oop. Bend that up. Now, this should still join. And it does. So we haven't broken that connection. So let's do the same thing. Actually, you know what? I went one step too far. Let's go back. I need to do this in 2 steps. So let's split this surface using these. Delete that, because I'm losing the connection here when I bent that up. Shrink trimmed. Turn the points on. Grab this. Bend. This still joins. Just checking to make sure. Now I split this. This is the object. Come on. This is the object to split. I'm using these guys. I delete this. Pick this surface. Shrink. Turn the points on. Grab these. And start here and go down. This should still join. If it doesn't, make adjustments so that it does. And then all we have to do is come in here and blend. And I'm going to back this off just a hair so those isoparams don't get quite so tortured going around the edge. And join. Yeehaw. Now, if I flip this over, it's a depression, right? So it's the exact same way. If you want it to go down, you just do it the opposite way. If you want it to go up, it goes up here. Now look at how cool this is. If I were to take this and built a little, you know, this is a little switch protector. If I put a little toggle switch in here or something, like how cool that would be. And depending on how much blend you need, you just make this gap bigger or smaller. If this needs to be sharp, you can make it sharp. If it needs to be fat, you can make it fat. Now, if you really want to get into the weeds, you could even do this with a blend and leave it at position. And that seems a little counterintuitive. I want to get rid of my interior shapes. I want that to simplify. It's a little counterintuitive, but then that gives you the option of, you know, really getting in here, and we could blend this edge. Let's preview it. Too much, said all. Too much. Still too much. There we go. And really start getting into some subtleties. Okay, cool. You like that one? This is one of my favorites. I use this. I do this for hood scoops for cars. I do hood scoops for cars this way. I do intakes for motorcycle fairings. I do bezels for switches. You know, you can imagine a toggle switch, you know, thrown in the center of this thing. It looks all fast and furious-y. Right? Something like that. We could take this guy right here and build it and stick it in here, and it would look all cool and integrated. All right, we're about 10:30. How we feeling? You want to see another one, or are you done? I'm good either way. I think we have time for one more if you want to get crazy. If not, we can call it a day. You guys have had to listen to me long enough. You gonna build this guy? Let's build that one. I think I can pull that one off relatively quickly. So let's throw this one on a layer. All right, so this guy has a little flat, it pops out, it has a little roundy, makes a tube, has some little details in here, and has a little piece up here that's got some, looks like it's tangent here, which makes it a little bit more difficult, but not impossible, because it looks like all the tangency happens within a quarter. So let's give that one a shot. We could actually do this with point editing, which would make it super interesting, or we could model it implicitly. Let me try with point editing and just see. Let's give it a crack. So let's start at 0, come out. I'm going to just do this sharply. And then I'm going to take this and gumball relocate. I'm going to put this up here to 0. And then let's go ahead and add some fillets to this. Why not? We'll do this a little differently this way. So let's fillet that. Let's fillet that. Let's fillet that. Actually, let's not do that last one. Let's do this one. Nope. Nope. Fillet's too big to fit in there. There we go. Let's do that. So we'll call that done. Whoa, tiny. All right, let's revolve this, and I want to revolve it from. I want to revolve it this way. And we can mirror this, but I'm not going to do that just yet. So if we want to do this with point editing, let's explode this, and then let's split this with isocurve to here, and then let's rebuild this to, I don't know, let's do like 15 and 15. And then let's turn points on and see what we can get. So this is our quarter points here. So I'm going to grab these. I'm going to leave these alone. I'm going to grab all of these. And I don't want to get these over here. Now let's see what happens if we just go burp. That's kind of what we want, but we need more points because I don't have enough points to get, well, maybe I can just modify these. There we go. And then I can take these. Yeah, that's kind of working. And then I can take these. And then I can take these. And those last ones need to stay put because they need to stay in line with these guys. But I can move them down. Now I've lost the I've lost the connection here, but I'm actually okay with that because I can always do this, split with isoparam and blend. And I would need to add some shapes in here clearly. And then I'm going to shift drag these out a little bit. Those are okay. I'm going to shift drag these out a little bit. And I'm not in love with that. We'd have to maybe give this a little bit more room. Maybe blend from like here to here. So let's do that. That probably is going to work better. I add these shapes to give the isoparams a little bit more room to run. I don't like how this is coming off at a straight line, so I'm going to Alt and I'm going to change the angle of that. That way it follows the shape a little bit better. That's better. I like that. Join it up. Let's mirror it. It's really fat, so let's scale it. And then let's blow a hole through it. The hole kind of needs to go through here. So let's use the same formula we did before. Let's draw this kind of like that. Completely making this up as I go. And I may actually make a rounded hole at the bottom of this thing. So let's do this. Because what that does is that gives me the opportunity to use a blend instead of having to try and surface model my way out of this. And that'll become apparent here in a second. So let's trim through this. And then what we should be able to do, if everything was working correctly, we should be able to blend from this guy to this guy. And let's make our shapes approximately in the same direction, going the same way. And I'm going to lock these together and drag them back. And it's not giving me enough, so I'm going to override it. And see how these isoparams are crossing down here? Check this out. I can explode this and turn on my isoparams, or turn on my curves, my points, and I can grab this knot of points right here and go over here and go smooth UVN, smooth in the U direction, and I can untie those. Yeah, bet you didn't know that one. And I just have to decide, because it's not symmetrical the way I did that, I'd have to decide which side I liked better. Let's see if it'll join up still. And I like the side that's joined over the side that isn't joined, so I'm going to just do a center line. Trim, mirror, something like that. Now, granted, if I wanted to get and you have this detail pull out a little bit, I would have to trim, I'd have to do a little bit more complicated blend on that. I'd have to, pull this down a little bit and then blend from here to the bottom and then blend the sides together and all that stuff. But, webinar. Add a few little details on here. Let's pull a few isoparams. Isolate the curves. I'm going to mirror these. And then I'm going to pipe them. And let's do a pipe radius of, let's do something small. You know, Boolean those together. Get rid of those little danglers. And there's our little detail. Which is cool if we have this thing, because I can bring this guy back. And that fits in there kind of nicely. Looks like something Vin Diesel would use to launch his car. We've got a cool little setup, right? Cool? Everybody happy with that? Well, I tell you what, let's we're at 10:46. Let me stop there, and then if there's any questions, let's take questions, and if not, I'll let you go, and we can all get on with our day. Hit me now if you want questions. If you need to get a hold of me at McNeil, my email is Kyle@McNeil.com. If you're interested in my other stuff, that's my business. Anything I can do to help you out along the way, let me know. I work tech usually Mondays. So if you hit the chat button on the Rhino website, you'll get me or John. If you're lucky, you'll get John Brock. If not, you'll get me. John is a lot more knowledgeable than I am. But anyway, all right. Any other questions? If not, I'll let you go. Thanks for coming. All righty, everybody. Have a great day.